In this video, we are going to review how to draw an energy profile diagram. An energy profile diagram is also sometimes called an enthalpy diagram. So just a couple of reminders. Endothermic. N means to enter. This is telling us that energy is entering from the surroundings. This leaves the surroundings feeling cold. So what does this mean in terms of the enthalpy? Because energy is entering from the surroundings, the enthalpy of the product will be greater than the enthalpy of the reactant. This means the heat content of the reaction, or the change of H, which is always calculated by products minus reactants, will be a positive number. What about an exothermic reaction? X means exiting. This means energy is exiting to the surroundings. And this leaves the surroundings feeling hot. In terms of enthalpy, that means the enthalpy of the reactants is greater than the enthalpy of the product, which means your change of H, or heat content of the reaction, which is always found by subtracting products minus reactants, will come out to a negative number. So a few rules on how to draw an energy profile diagram. The first thing is we need to rule our axes, and we need to label them. Now the x-axis is the reaction pathway or reaction coordinate or progress of reaction. The y-axis is enthalpy, and sometimes we label it with the symbol H. You need to work out if it's endothermic or exothermic and position the reactants and products accordingly. And don't forget to label them. So you label them with the reaction itself. You need to draw an activation energy because all reactions require energy to break bonds, but you also need to label it. And you need to label the heat content of the reaction, which is also called the change in enthalpy, and label the transition state or activated complex. Let's draw an example. So in this particular reaction, we've got hydrogen gas reacting with oxygen gas to give water gas. This is commonly called the POP test. This reaction, you can see the change of H is negative. This is telling me it's an exothermic reaction. So that means energy is exiting. So the surroundings feel hot. Now we need to represent this on our energy profile diagram. So the first thing we're going to do is label the axes, reaction pathway, and enthalpy. Now because energy is exiting, this means that I'm going to start with the enthalpy of the reactants being higher than the enthalpy of the products. The reactants are 2 hydrogen gas plus oxygen gas. The product is 2 water gas. Now I have to put in an activation energy, and it doesn't require a lot of energy to set the POP test off, but it does require a splint. So I put a bit of energy in, and this represents the activation energy. So I label the activation energy, and I label it EA for activation energy. The change of enthalpy, which is change of H, and I put in change of H equals negative 572 kilojoules, and I labelled the activated complex. try another example. In this particular reaction, we have nitrogen gas reacting with oxygen gas to give 2 nitrous oxides. The change of H is positive 33 kilojoules. So this is telling us that it is an endothermic reaction, which means energy is entering. This will leave the surroundings feeling cold. Now let's go through the process. We label our axes. So this is the reaction pathway. This is enthalpy. And I need to position my reactants and products. Now because this is energy is entering, I'm going to start with my reactants here, and my products are going to finish up here. My reactants are nitrogen gas plus 2 oxygen gas, and my product is 2 nitrous oxide gas. It will have an activation energy, which I need to label as well. So I'd show the activation energy is here. The heat content of reaction or change in enthalpy is here, and it's positive 33 kilojoules. And the activated complex or transition state is at the top. And remember, at the transition state, this is where all the bond breaking or bond forming goes on.